Hello and welcome back. Let's continue to look at implicit differentiation. So for instance here, like I mentioned at the end of the last video, we were trying to find the derivative of y with respect to x. And one thing that we're quite often tempted to do is just try to solve for y, and then whatever function we get, we'll just take the derivative of that. Here, this would be essentially impossible to try to solve for y. This won't have a nice closed form solution for y, as in I can't try to solve this for y and write y is equal to something. This just doesn't work. So we're going to have to use a different method, namely implicit differentiation, to solve for the derivative here. And in fact, I think that it's actually quite easy in the long run. Implicit differentiation is very, very helpful in a lot of situations. So let's just take our equation here and take the derivative of both sides. So I've got the derivative, and again we're finding the derivative with respect to x of xy cubed, and then I need to find the derivative of x cubed y. On this left-hand side, I have a product. I have x times y cubed. So what I'll do is I'll use my product rule, and I'll take the derivative of the first term times the second plus the derivative of the second times the first. And I'll do the same thing on this side. So I've got the derivative of x cubed times y plus the derivative of y times x cubed. And let's just go down the line and take some derivatives. So here I have the derivative of x with respect to x. Well, that's just going to be 1. Again, the derivative of a straight line is just going to be its slope, so that's just going to be 1. And y cubed is just y cubed. I'm not doing anything with that. Here I'm taking the derivative of y cubed. So here, again, I'm going to have to use my chain rule because I have essentially a function cubed. So I'll bring down the 3 and raise it to the 1 fewer power, and I need to take it times the derivative of the inside. Well, the derivative of y is just the derivative of y. And then all of this is times x. So here, this guy matches up with that by using the chain rule. And this is just to remind us where this guy comes from. And then over here, I've got the derivative of x cubed. And again, I just bring down the 3 and raise that to the second power. I don't have to use the chain rule here because the x in the middle is just an x. It's not an entire function. And then I take this times y, and then I will add the derivative of y with respect to x. Well, the derivative of y with respect to x is just dy dx, and all that is times x cubed. So this last bit is just a bit of algebra. I am trying to solve for dy dx. This is what they're asking me to find. So what I'm going to do is I'm going to collect all of the dy dx's on one side of the equation, move everything else to the other side, and solve. So I'm going to put all my dy dx's on this left-hand side. So I'll collect all of this. So this is going to be 3y squared, I don't want to forget the x, 3y squared x times dy dx. I'm going to move this to the other side, so I'm going to subtract. I'll put the x cubed times dy dx. So I just took my two terms with a dy dx and moved them to this side. And then I'll do the same with the terms without a dy dx. So here I have 3x squared y, and I'll take this last one and I'll subtract, 1 times y cubed is just y cubed, and I'll subtract y cubed. And if I factor out the dy dx, I have a 3, I'm going to put all my x's in front of my y's, just to be consistent, it doesn't matter. 3xy squared minus x cubed, and that's going to be equal to 3x squared y minus y cubed. And if I solve for dy dx, I will get dy dx is equal to 3x squared y minus y cubed, all divided by 3x y squared minus x cubed, which is a pretty big derivative here. I have dy dx is equal to this pretty big fraction, but again, I wasn't able to solve for y explicitly, so I can't just take the derivative of whatever y is equal to. I have to use implicit differentiation. And it was pretty straightforward. We just had a couple of product rules, and then I have to remember the chain rule whenever I'm taking the derivative of something with a y in it, because the derivative of y is dy dx. Let's do more. Here, this is kind of like the situation we were talking about before. I'm going to be taking the derivative with respect to t, and I have p here, which is going to be some function of t. So p minus t divided by pt is equal to 5. Let me start down one track and then show you a trick to make this a lot easier. So in the past, when we've been looking at just taking, you're using implicit differentiation, what we would normally do is we would just try to differentiate both sides. And this would absolutely work. This works. There's no problems with it. However, it's harder than it needs to be, because over here I've got a fraction and then I'd have to use the quotient rule. So what I'll do is I'll say that this is hard. And there's in fact an easier way. If I have a fraction here, I don't really need a fraction, do I? So I can multiply both sides by pt, and I can see that p minus t is equal to 5 times pt. So I just multiply both sides by pt. This is going to be a lot easier to take the derivative of. I can take the derivative with respect to t of both sides. And this is going to be a lot easier to take the derivative of now that we don't have a quotient rule. So let's continue doing that. Oops. So on this left-hand side, I have the derivative of p minus t. So that's just going to be the derivative of p minus the derivative of t. Over here, I can pull the 5 out because it's just a constant function. And then I have the derivative of pt. So this is just going to be a product rule. So I'll take the derivative of p times t plus the derivative of t times p. And this is how our product rule works. We take the derivative of both of them times the other one. So the derivative of p with respect to t, well, this is exactly what we're trying to find. The derivative of t with respect to t, it's just 1. And it's going to be equal to 5 times this mess. So this is going to be the derivative of p with respect to t times t plus the derivative of t with respect to t, well, that's just 1 times p. And then the last bit here is just some algebra to rearrange this. So this is going to be the derivative of p with respect to t minus 1 equal to 5 t times the derivative of p with respect to t plus p. And after moving some things to the other side, so let me go through this carefully. I've run out of room, so I'll just do this to the side. So I have that here. I'll move this guy to the other side. So this is minus 5t dp dt is equal to, well, I have this oh, I needed to have a 5 there, didn't I? Right, because I have to distribute the 5 to both of them. So then this would be 5p, and then I'm subtracting 1 there, so I'll add 1 to that side. And we're nearly done. I can pull out a dp dt. So I'm left with 1 minus 5t is equal to 5p plus 1. And solving for dp dt will be 5p plus 1 divided by 1 minus 5t. So a little bit of algebra there at the end to try to solve for dp dt, but ultimately, yeah, it's using implicit differentiation. We can even use a trick at the beginning to make it an easier derivative to take. But implicit differentiation, I would not consider hard if you're being careful.